Right, so what we're going to do today, we're going to continue with derivative, but now we're looking for the derivative's trig function. Okay? Yeah, and we're going to start by, if we've got a function f of x equals sine x, we're going to try and find out what is the derivative of. Okay, in other words, what we're doing, I'll write it in different ways. Well, I just always try to write all the different notations so you feel comfortable with that, okay? So we've got a sine of x, and we try to find the derivative of that, okay? That, in other words, is the derivative of f when f is sine x. Now, I did make a video where I actually proved, I calculated that properly from first principles, but I'm pretty sure it's above the level you need for the course. It is in the book, it's written in the investigation, but I really pretty much think that it's a little bit above. But I made a video and I'll post it to you later. What I want to do now is, I guess, not maybe prove it, not calculate it, but convince you. That's what I'm trying to do. So this is the Sine X graph. By now, I'm sure you guys are familiar with that. Maybe not as confident with the radians, but I think it is, you know, let's put it this way. When you go to university, you do maths, engineering, anything, physics, it's all radians. So we don't deal with degrees. So I think it is important to remember that, okay? So 90, 180, 270, 360, okay? 2 pi, just remember 2 pi is 360, and then everything comes from that. What is the derivative? What is the meaning of the derivative of function? If this is a function, what is the physical meaning of the derivative of that function? Value of the gradient. So again, it's not a proof, but let's try and evaluate the value of the gradient. Okay? So we'll start from 0. Obviously, the same thing happens if you go to negative angles. Okay? But let's start at 0. What's the value of the gradient? I'm not expecting a number, but just tell me, is it positive or negative? It's positive. And in fact, what happens to the gradient as we move on from 0 to half pi? It gets smaller and smaller and smaller until we get to half pi. It's exactly 0 because it's horizontal. So what I'm gonna do here, maybe another color. Okay, I'm gonna plot the derivative of f. Okay, so we start with a certain value. We don't know what that is. It could be 2, it could be half, it could be 17. Okay, and we start from here, and as we go from 0 to half pi, like you guys said, the gradient goes to 0. What happens after half pi? From half pi to pi, it goes negative. And in pi, it's the maximum negative, if that makes sense. It's the lowest number. Okay? And then after pi, what happens is it's still negative, right? But it becomes closer and closer to 0. At 3.5 pi, it goes back to 0. That wasn't good. Yeah, it is good. So at half or 1.5 pi, it goes back to 0. And then after 1.5 pi towards 2 pi, it goes back, becomes positive again, and reaches a maximum. The same maximum, the steepness here and here is the same. So it has to go back to the same value here. Okay? That's a cos graph. Exactly as a cos graph. Okay? So I didn't prove it to you. What I did show you, convince you, let's say that the derivative of a sine graph is simply a cos graph. Okay? Alright, like I said in the video that I added, I actually prove it from first principle. But to do that, you need to learn a few limits that we haven't dealt with. Okay, so now I'd like to know what is the cosine x to dx. So we find the derivative of sine. Let's try and find the derivative of cosine. Any guesses before we go along? There might be a sign there. Okay, so I'll put question mark. Okay, I can do the same thing by drawing the graph, but I'm going to do something else that they did in the book, which I think is quite neat. Okay, so rather than working with the graph, what I'm going to do, I'm going to use, I can't remember what you call it. It's not an identity. It's a way of moving from cosine to sine. So If I was insisting to work with sine, I can write that as, what should I write? So there's going to be an x here, but not sine x. It will be sine 90 minus x. What do we call that one?
The co-function.
Co-function. But because we're working with radian, I work with half a pi. Okay? So that's great. So if I want to find out d cosine x to dx, all I'm going to do instead is find d sine pi, half a pi x minus x to dx. Because I already know how to work with sine. Okay? Now, here comes the thing that I think you're still not strong with that, but it's really important, is the chain rule. Chain rule is so important. I was thinking about it, and it really is, like, I can't think about a question where you have derivatives and you don't use the chain rule. Okay? So, df of g of x to dx. If I've got a function of function, I want to find the derivative, I need to do the derivative of the outer function, derivative of fg of x, and time by derivative of the inner function. Okay? So the outer function is simply sine. Okay? What's on the outside? So the derivative of the outer function is simply going to be, I'll write it down like this. I think it's going to make, okay, it's going to be too confusing. What's the derivative of sine? We already found out. What's the derivative of sine? Cos. So I'm going to just write cos, whatever is inside here. Here, there was just an x, so it became cos x. Now I've got sine of half a pi minus x, so it's going to be cos half a pi minus x. Okay? But now I need to multiply it by the inner function. And what is the inner function? It's that one. Half a pi minus x. What's the derivative of half a pi minus x? Minus 1. Okay, the half a pi doesn't contribute to anything because it's a constant. But because I've got minus 6, I've got minus 1. So I need to multiply by minus 1. In other words, it's equal to minus 1. I'll just take my time here. Cos half a pi minus x. Now I'm going to rewrite it again. d cosine x to dx. What is cos half a pi minus x? What can I change that to? Sine x. Just like we changed, you got sine x. I'm not going to write it. It's quite obvious. I can just do 90 or half a pi minus brackets half pi minus x. That's going to give you x, right? So that's equal to sine x. So was Rachel correct? Is it just sine x? There's a minus. So you were very, very close. Okay? There's a minus there. Okay? So the derivative of sine is cosine. The derivative of cosine is minus sine. Find it. Okay, so is that working? Yeah. So what we're going to do now is find the derivative of tan. This was actually where we worked hard. The rest should be relatively easy. So instead of tan, obviously tan, I'll write it like this. The derivative of tan x to dx. What is tan? Tan is simply sine over x, of course. Okay? To dx. And now we have to invoke the quotient rule. Did I say it right? Quotient rule. Yeah? What was the quotient rule, if you remember? Derivative of f of x divided g of x. If I divide two functions by each other and I want to find the derivative, okay, it's f prime g. Oh, running out of space. Let's write it again. Okay, so df over g, both of them function of x, to dx is f prime g minus f g prime, yeah, divided by, do you remember? Get rid of that one. Like that. Divided by g squared. Okay? So now I've got the f and I've got the g. Okay? So it tells me, alright, do the derivative of f. What's the derivative of sine? Cosine. Okay? Time it by g. Time it by cosine. So I've got cosine squared. Okay? Then it tells me minus. Now just take f, which is sine, and time by the derivative of g. What is the derivative of cosine? Is minus sine. So time minus sine x. Okay? You've got something that looks long, but actually is really easy. And divided by g squared. G was cosine, so it's cosine square x. Okay? Now what do we have here? Cosine square x minus time minus is plus sine square x divided by cosine square x. What can we do straight away? Screaming at you.
It's 1.
It's 1. Okay? Cosine plus sine is squares of cosine 1 to the sine add up to 1. So it's 1 over cosine squared, which we can write as sec, you call it sec, S-E-C, 6x. Yeah? Right, the sec is 1 over cosine. Is that how you write it? I just want to make sure. Yeah.
Isn't that also an identity? Sec square x.
That's not an identity, that's a definition. If there's a difference. The sec is defined as 1 over cosine. So sec squared is going to be 1 over cos squared. So I'm going to write it down here. It's basically sec square x. Okay? Are we alright with that? Now you can, and there's an exercise there where you have to prove, to find out what's the derivative of cotan, sec, and cosec. There's a question, and I would really do it. I will do it if I you in the exercise. I will do one of those for you, the first one. Okay? So I'm going to try and let's find together the derivative of cosec. Cosec x to dx. Okay? Let's do that. Okay, so d cosec x to dx. What do you reckon the first thing we need to do? See your instinct. Because I don't know what cosec, I don't know how to turn it into something that we can read. What is cosec? Do you remember? 1 over sine.
So can I ask you,
I'm just going to pause here. Right, so now I know what is I know what I need to calculate. I need to calculate the derivative of 1 over sine. Now there's two ways of going here. I can either say, okay, I can use the quotient rule, where f, what is f is equal in this case? What's the function at the top? 1. And then g is sine x. And I can just use that formula. Or, and I am going to do it, I know you struggle more with this, I'm going to use the chain rule, okay? So 1 over sine x I can also write as sine power what? Minus 1. Okay? And now suddenly I only have one function. So I don't need the quotient rule. I'm going to get rid of it. Okay? What we do need is the chain rule. Okay? Right? What is the outer function in this case? Power minus 1. So the outer function, so I'll write again the chain rule. The chain rule will tell you that if df of g of x to dx is f prime gx times g prime x. Okay? In this case, I'm going to write it here. The outer function, the f of x or f of g of x is like, I don't want to write x, so I'm going to call it u to the power minus 1. Okay? I'll write it f of u. And the u as a function of x, that's the inner function. What is the inner function? Sine x. So what I've got here is f is u power minus 1, and the inner function is sine x. So this thing tells me, I'll write it now in the same language that we have here. We have f of u of x. I should have really used g. So it's going to be the derivative of f prime u of x. Yeah, I don't know why I should have just used g. Okay? Time u prime x. So what is the derivative of u power minus 1? Minus u. And instead of, okay, I'll write u in for now. Minus u to the power minus 2. And instead of u, I'm straight away going to write, what is u equal? Sine x, right?
Yeah.
So I'm just, instead of u, I'm straight away going to write sine x. Okay? I should really do the minus 2 here. I think when you do the power of the sine, you put it like somewhere in the middle. Because if you put it if you put it at the end, it looks like x is minus power 2, minus 2. Okay, I'll put brackets here just in case. And then I can, if I put brackets, then I can put the minus 2 there, and it's not ambiguous. And then I need to calculate the derivative of u prime x. What is u prime x? U is sine x. So what's the derivative of sine? Cos. Okay. All right. So now let's write it in a nice way. It's going to be minus cosine x divided by sine square x. Okay. Now I'm just going to pause here for a second because this is kind of my answer, but maybe they want me to beautify it a little bit, and I'll check. Okay, so u, by the way, you can do the same for d, find the derivative of the sec and find the derivative of the cotan. In the formula, you get that in the formula sheet, so you don't need to remember it. But I think it's really important to know how to deviate that, because that could be a question in the test, this could be a question in the test, but also is the skills that you need for this are important. Okay, now if you look at the formula sheet or in the textbook, that's not the final answer. So I'll just show you what they did to get the final answer. What they broke it up to minus 1 over sine x times cosine divided by sine. Can you see what I've done here? They just split the sine square into sine and sine. Okay? And then what they did here, and I'll write that as the final, d cos sec x divided by the derivative with respect to x. Okay, what is minus 1 over sine? What's that? It's cosec. So I've got minus cosec x and cosine over sine? Cotan. Cot. C-O-T-X, right? Is that how you write it? It's the inverse of the tan, 1 over tan. Okay, and that's what they've got. So I'll just check that is right. Yeah, you've got a table there in page 30, and I think they ask you to find out all the other derivative, all the trig functions. Okay, right. I'll pause here. How are we on time? Okay, so now we're going to do examples, and for the examples, you need to know the basic derivative of all these trig functions. I only have 3 here, but the rest are on page 30. But as I said before, what you really need to master is the chain rule. So the derivative of sine is cosine. But now I'm never going to give you find the derivative of sine x. That's just easy. Okay, so the first one, the first level of difficulty will be sine 5x. Okay, and I want to find out the derivative. What will it be, do you reckon? So I've got a function of a function, right? So I've got to use the chain rule, okay? It's going to be the derivative of the alpha function, which is just sine. So that's going to become cosine 5x. And then I need to time it by 5. Because that's the derivative of the inner function. The inner function is 5x. Okay? So very simply 5 sine x. You see, it's a certain, 5x. It's a certain instinct that you're developing here. Now you're finding the derivative, cosine, okay? You kind of like the 5, whatever is multiplied by x jumps up. Okay? So again, that's the easiest. Okay? A little bit more tricky is that business now. Now actually I can use the product rule. I can say cosine, I've got cosine squared 3x. So I can write it as cosine 3x times cosine 3x. Find the derivative of each one of the cosine 3x. Use the product rule that, if you remember, okay, f times g derivative with x is f prime g plus f g prime. But that is not needed. I can write chain rule, but I'm going to have to use it. It's a triple chain rule. Okay? Look, cosine 3x is cosine 3x squared. Okay? So what I'm going to do now, I'll find the derivative. I've got 3 functions here. The outer function is squared. The middle function is cosine. And the inner function is 3x. So, yeah, it's the small babushkas here. And I multiply, okay, maybe this is really good because Now I've got, let's write it down in fact, okay? If I've got, in this case, I've got f of g of h of x. I've got 3 layers of babushka, okay? I'm going to get rid of that. I'm not going to use that. So it's going to be f, the derivative of f of g of h of x, times the derivative of g of h of x, times the derivative of h of x. It kind of makes sense. You just get used to it, okay? So what will be the derivative of the outer function? That's squared. Imagine this whole thing is u squared. So what will be the derivative? 2u. Or in other words, 2 cosine 3x. Okay? Now we multiply it by the one below, cosine 3x. Okay, we've done that's similar to what we've done here. So cosine becomes almost minus sine. Okay? Minus sine 3x. Okay? So that was the derivative of the middle function. And now we multiply by the inner babushka, which is just 3x. So we multiply it by 3. And the answer is 2 times 3 times, so it's minus 6 cosine 3x sine 3x. And we can possibly use some kind of identity here, but they didn't, so we're not going to do it as well. Okay, you can, I don't know if you use the double angles. I think you can probably turn that into a double angle. I don't know if you learn these sine 2x equals 2 sine x cosine x.
I know you gave it to us.
Yeah, but it's never, I'm not going to do it. They didn't do it, so it's not a problem. Okay, I'll pause here. Okay, so our next example is a function x tan x. So we got a combination of a trig and a normal polynomial, I guess you call it. And the derivative of that, what we're going to use here, this is a product, multiplication. So we're going to use the product rule, which are erased and wrote again here. Okay, so it tells you find the derivative of the first function, time it by the other function, plus find the derivative of the function, first function times the derivative of the second one. Okay, and we've got everything here. So what's the derivative of x? Dx to dx. 1. Okay? And then we time it by tan x plus x times the derivative of tan x, and you're not supposed to remember it. It is on the formula sheet, and I've written that one. It's sec square x. So the answer is very simple: tan x plus x sec square x. What you can see here, that actually, how shall I say it? Derivative of trig is quite complicated. It's nasty. I mean, it's doable, but it is a little bit nasty. And I'm just going to slip that in here. When we were working with, e to the power of, well, I didn't really completely talk about it, but I'm just going to put it there. We talked about the number I. Okay? And why we use it so much. The reason we use it so much is that there is a formula that I haven't really discussed it, but I'm just going to quickly show it here. Okay? E to the power of I theta. There's a very important formula. It tells you that it's cosine theta plus I sine theta. And that's called Euler Formula. And we're not going to use it here. But what it does, it connects a trig function into an exponent. And the thing you will notice later on, not too long, another few weeks, that the derivative of exponents are dead easy. Really, really easy. Much easier than trig. So if we can convert a trig to exponent, this makes the job much easier. And that's why. This is the reason why we use the imaginary number in physics. Okay. So let's just pause here and write more last example. Okay, so the last example looks complicated. It's a little bit long, but it's not complicated. They give us a function, okay, sine over cosine, or 2x, 4x. And instead of asking us to find the derivative, okay, the wording could be a bit confusing in the beginning. They're asking us to find the gradient at the tangent to this curve at x equal pi over 6. What does that mean? I mean, this thing is a curve. Okay, f of x, sine 2x over 4x, some kind of curve. And at x equal, I'll write it down here, at x equal pi over 6, there's a tangent. and we need to find the gradient. So in other words, you got to find out the derivative, okay? And then substitute x equal pi over 6. So it's easy, okay? So let's try and work out, yeah, no one need that. The f prime. So we're going to use the quotient rule. I erased it, but we remember it now. Okay, we find the derivative of sine 2x. Okay, we use the chain rule for that. Okay, so it's 2, maybe I'll write in a couple of stages. So I need to find the derivative. Okay, I'm going to find the derivative of sine 2x. I'll write it down like this. I'll find the derivative of sine 2x multiplied by cosine 4x. Okay, and get rid of the chain rule now, or the product rule. And then I'm going to minus that by sine 2x and multiply by the derivative of 4x. And all that divide by cosine 4x squared. Okay? Now, I need to do it. Okay. So what's the derivative of sine 2x? Well, the derivative of sine is cosine. So it's going to be cosine 2x, but I got to multiply by the 2, the inside. So it's 2 cosine 2x, chain rule. Multiplied by cosine 4x. Minus, I'm just copying, sine 2x. Okay, now I need to find the derivative of cosine 4x. So there is a 4 jumping out. First of all, cosine becomes sine, so I need to have a minus. So it's going to be minus sine 4x, but like you said, you multiply it by 4. Divided simply by cosine square 4x. And that's it. Well, not exactly. Now I need to put in x equal pi over 6. And I'll be honest with you, I think let's just do it. Let's just do it. A little practice. So it's going to be 2 cosine. Let's do it straight away. What is 2 times pi over 6? Pi over 3. Right.
Could you simplify the equation a little bit?
I could. Can I?
But you don't have to.
It's probably possible, but I think it's very difficult. So I've got cosine times cosine.
Because the angles are different.
Yeah, exactly. Probably there is something to do. In fact, I'm pretty sure there is. That is probably an addition. I'll just check if they've done it. They didn't do it, but you can. If you use the adding angles formula, I think that might be a sine something. But actually, yeah, maybe even not. Okay. Anyway, now cosine 4 times pi over 6. What is 4 pi over 6? Is 2 pi over 3? Okay. 2 pi over 3. You must check me here because I could make a mistake. Now I've got minus pi minus, so that's plus n before, that's 4. Sine 2 times pi over 6, again, that's pi over 3. Sine 4 times, we did that, that's 2 over 3. 2 pi over 3. Divided by cosine squared. 4 times pi over 3 is 2 pi over 3. Okay? Alright. Let's do it, Rachel. Come on. Pi over 3. Pi over 3, remember pi is 180. If 2 pi is 360, pi, obviously you can put that in the calculator, but I think these are all special angles. So pi over 3 will be 60.
Pi is 360. No, 2 pi is no. So pi is 1, yeah.
60. So what is cosine 60? Is half.
Yeah. And then you draw my triangle.
Okay, so it's 2 times half. And what's that? 120. That's minus half. I'm hoping we're right. I'll just check. Yeah. Yeah, I'm just checking with them. So that's minus times minus half. Okay. Plus 4. Sine 60. Sine 60 is also a special angle, not as pretty as half. Square root 3 over 2. And then sine 120 is also square root 3 over 2. It's not minus because the sign is positive from 0 to pi. Cosine, what did we say? This is cosine 120 is minus half, so we've got minus half squared. Okay? Alright? 2 times half is 1, so I've got minus half plus 4 divided by 2 times 2, that's the same, so it's 4 is plus 3. Square root 3 squares 3. Divided by a quarter. So I've got 2.5 divided by a quarter is 5 over 4 times 4. We got 5. I think they got 10. We made a mistake. I made a mistake here, or they made a mistake? I think they made a mistake because they got the same here. They got minus half plus 3 divided by quarter. Check me out here. Minus half plus 3 is 2.5, which is 5. It's 5 over 2. It's 5 over 2. This is where I made a mistake. Yeah. So 5 over 2 times 4 obviously is 10. So they were right. Okay. That's it.